So the notes for Integrated 2, 6.1.1 and 6.1.2. So we're going to talk about special right triangles and on a much minor level, the idea of a Pythagorean triple. So one of the things that you already experienced in the assignment was the idea of trying to construct a 30, 60, 90 triangle. So now there are only two special right triangles, one of which is the 30, 60, 90. So we're going to focus on the 30, 60, 90 triangle first. The sides that we use, or the ratio that we use, is A root 3, and 2A. That's also in ascending order of size. So we would say that A itself, that's the small side. So again, ascending order. A root 3, that is the medium side length. And then 2A, we would say, is the larger long side length, where we know this one, this large one, if it's a 30, 60, 90, so there's 90 degrees, this is going to be the hypotenuse. Okay, so what we have over here on this slide is just the version of the picture. So if we take a look at this, I want to go through and identify the sides. So as a reminder, we already talked about the smallest angle is partnered with the smallest side, if you want to think about it that way. So if we start at the 30-degree angle and we go across from the 30-degree angle, we know that 30 is the smallest angle, which means opposite it is also the smallest side. So that's where the A is. So smallest angle, smallest side, as we know. Okay, largest angle is going to be the 90 degrees. If we go across from that, that's going to be the largest side, or the longest. And then if we start at the medium size angle of 60, then we know opposite it is going to be the medium side length, which is going to be A root 3. Now, what's really nice about this is this pattern is consistent for all 30, 60, 90 triangles, regardless of the side lengths that are on there. Now, we're using A. A in this case just represents a dummy variable. You could call it X if you wanted to, or question mark, or smiley face, whatever you want. We typically use A or X, so that's normally what you're going to see. And that's what you're going to see over here on the left-hand side. So notice all of these things, type of things that I just talked about. Okay, there is a second special right triangle. This special right triangle is the 45, 45, 90 triangle. We refer to these special triangles based off of the interior angle measures. So the 30, 60, 90 triangle has a 30-degree angle, a 60-degree angle, a 90-degree angle. Same thing with the 45, 45, 90. So if we take a look at this ratio, this one looks a little bit different. This is A and A root 2. We only identify two of them because if two of the angles match, we know the two sides match. So the A, and again in ascending order, this A represents the shortest side, but it's also the legs. So we know if the 45s are going to match, then we're going to have two sides that are the same length. So I would say you could call this the small side, but I think I'm just going to refer to it as the legs. Whereas the A root 2, this is the large side. Well, we're still talking about a right triangle, which we know this means that that's the hypotenuse. And we can go through and identify the sides the same way that we did previously. So if we start at the 45-degree angles, each of them, we know that those angles are the exact same size, which means opposite those angles had better also be the exact same length. So these are the legs that I'm referring to. So that's a leg, this is a leg. And then opposite the box, we know is going to be the longest side, or the largest, which we also know is the hypotenuse. Again, this pattern doesn't change either. It's actually really kind of nice. It's nice and consistent. It doesn't really matter what the numeric values are on there. This is the pattern between them. Okay, Pythagorean triples, before we get into some examples here with using the special right triangles. Pythagorean triple really is three numbers that satisfy the Pythagorean theorem, but the best part about them is that they are integers, which means no square roots, no fractions, no fractions, no decimals. So these are really, really nice. Hands down, the most popular one, which you're going to see quite a bit, is, and again, my pictures are not drawn to scale. So the hands down most popular Pythagorean triple you're going to see are lengths of 3, 4, and 5. It's actually pretty special. But here's the idea. Notice that all of 3, 4, and 5 are really nice answers. So there's no like square root of 7. We don't have to worry about that. There's no decimals. There's no fractions. There's no way there'd be negative numbers. So that's kind of beside the point. But if we go through and we see if this satisfies, I'm going to put a question mark over that, satisfies the Pythagorean theorem. Okay, well, we know that 3 squared is 9, 4 squared is 16. Let's go ahead and finish this side. We know that that is 25. Okay, I'll put my question mark here, 25. Okay. So a Pythagorean triple are really 3 numbers, triples, that satisfy the Pythagorean theorem. So a squared plus b squared equals c squared. But they're integers, so you don't have to worry about there being fractions or decimals or any kind of funny business or even roots with them. So they're just nice. That's all. They're just nice numbers. Okay, so here's what we want to do. We want to see if we can identify what the different side lengths are that we are missing. So we need to be able to get an answer for a and b or x and y or whatever is given to us. So if we take a look at this, most important thing, or the big thing that you want to do first, is try to determine what type of a triangle this is. Well, I can see it in the picture. This problem is going to be a 45, 45, 90 triangle. I know this because this 45-degree angle is already given to me in the bottom left-hand corner. The 90-degree angle is also given to me, and then using triangle sum, I know for sure that angle is going to have to be 45 degrees. Okay, so now what I like to do, you don't have to do it this way, but I'm a big fan of going through and identifying my sides. So if I go across from the 45, I know that based off of the pattern, that is A. Across from the 45, that is also A. And then across from the box, again, I'm just using the pattern here. This is a root 2. Now at this point, what I want to do is I want to inspect the 3 equations that I just created. So I created a b equals a. Well, I have no idea what either a or b is. So that equation I'm going to wait on because I don't have a numeric value there. I'm also going to take a look at the a equals a. Well, of course a equals a, but I still don't know a numeric value for a. So I'm going to wait on that one. Then I'm going to take a look at this equation. You'll notice there's only one unknown in this equation. Okay, this is good. So I'm going to take that equation off to the side, and I'm actually going to solve for A, because in the 45-45-90 triangle and the 30-60-90 triangle, the key is A. If you can find A, you're home free. So we're going to take this equation. So we've got a root 2 is equal to the square root of 34. Now we know if the a and the root 2 are pushed up against each other with no operation, that's technically a multiplication that's happening between them. So I'm going to get rid of that multiplication by dividing by root 2. Whatever you do to one side, make sure you do it to the other side. Okay, on the left-hand side, I know that root 2 divided by root 2 is 1. So they are going to simplify, and I just have a, so that's good. On the right-hand side, notice that both the 34 and the 2 are inside the square root symbols. There's no addition or subtraction. It's just multiplication or division. Those are fine. So what I can do is actually pull them back together inside the exact same square root. So I'm just going to go ahead and merge those two. Now that they're both inside, I can actually divide. So it's going to give me the square root. Keep the square root symbol with you. That's going to give me 17. I take a look at this. I have no square root in the bottom of the fraction. That's good. I don't have to rationalize it. And it looks like I now have an answer for A. Finding A will set you free on these problems. So once we know A, we're going to go back up to the original picture, and everywhere I have an equation that I didn't have an answer for. So like x equals A or y equals B, stuff like that. I'm going to plug in what I just found out. Well, I just found out that A is equal to the square root of 17. So if I take a look down at the very bottom of the triangle, I see a equals a. Okay, well, there's no numeric value there. Plug in what I know. Well, that's a, and I know that a is equal to the square root of 17. So there's one of my answers. I'm going to take a look at the other side where I had two variables equal to each other, and I'm going to plug in what I know. Well, a was equal to the square root of 17. So it looks like I actually have my answers. So the two answers, I needed an answer for a and an answer for b. So the answer for a was equal to the square root of 17, and then I take a look at where b is, and it looks like b is also equal to the square root of 17, which it should be because, remember, we are talking about a 45, 45, 90 triangle, and the legs should be the exact same length. All right, let's take a look at the second one. Same idea. You have to identify what type of a triangle this is. So if I take a look, I've got a 60-degree angle, a 90-degree angle. Okay, using triangle sum, that's going to have to be 30. Now I'm going to go through and do the exact same thing that I did previously, using the pattern that I know from this specific triangle. So if it is a 30, 60, 90 triangle, I know that opposite the 30 is the shortest leg, and that is identified as A. I know opposite the 60-degree angle, that is the medium side, this is equal to a square root 3. And then starting at the box, going to the opposite side, I know that that is 2a. So using it straight from the pattern. Okay, let's take a look at these. So we're going to inspect them again. So a equals a. That doesn't do me any good. I have no idea what a is. 12 is equal to a root 3. Okay, this one I can solve for. You'll notice in this equation there's only one unknown value. So I'm actually going to use that one. So let's go ahead and write that equation off to the side because we need to do a little bit of work. Remember, it doesn't matter what type of a triangle it is, 45, 45, 90, or 30, 60, 90, A is the key. So if we can find A, we can do this. All right, with the A and the root 3 pushed together, that's technically multiplication. Let's go ahead and divide. So I'm going to divide by root 3. On the right-hand side, I know root 3 divided by root 3 is 1. So it looks like I have A is equal to 12 over root 3. All right, I've got a square root in the bottom of a fraction. I can't leave it like that. So the problem is the square root of 3. So I'm going to multiply the top and bottom of the fraction by the square root of 3, which is fine because square root of 3 over square root of 3 is just 1. Remember, when we multiply fractions, we go straight across. So root 3 times 12 is going to give me 12 root 3. Multiply straight across on the bottom, I'm going to get root 3 times root 3. Okay, let's see if we can skip over a step. We already did rationalizing. We know that square root of 3 times the square root of 3 is still going to be the square root. Now we're going to multiply the 3 and the 3, and we get 9. So get the square root of 9. But the square root of 9 is 3. So let's go ahead and just put a 3 down there. Okay, I'm almost done. I think this can be simplified just a little bit further. And the more I simplify, the easier it will make my life as I go through these problems. So this 12 and this 3, neither of which are inside a square root symbol, those can be simplified. I know that 3 goes into each of those. So 3 goes into 12 4 times, and 3 goes into 3 once. This is good. It doesn't look like I have a denominator anymore. So I just have 4 root 3 is equal to a. Okay. That, remember, A will set you free. You want to have A. All right, let's go back up to the picture. Everywhere we see an A, I'm going to plug in a 4 root 3. Now, if you take a look at what I highlighted in blue back in the picture, I already know what that length is. It's 12. So I don't really have to find it. But I do need to find what A is. So I'm going to go back up here where A is. And I know that A is equal to 4 root 3. So just kind of plugging in my A into the little equation. Okay, so there was a 2. There's the A. Let's pull it out. Inside where the A is located, we're going to replace it with a 4 root 3. Okay, that was B. All right, we're not done yet. We need to multiply the 2 and the 4. Notice that this 2 and this 4 are not inside a root, which means we can't actually multiply. So 4 times 2 gives me 8. Don't forget to bring the root 3 with you. Looks like we have all the answers. So A was equal to, well, that was the answer that we got. Remember, A is the key. And then B we got as 8 root 3. Okay, so there's our answers for this. All I'm doing is utilizing my pattern to be able to solve for the things that are missing. All right, now we've got a whole bunch of these. My recommendation to you, see if you can do question number 1. So pause the video, see if you can do it. Come back and check your work against mine. Okay, so here's the work on question number 1. I'll be honest with you, this is hands down my favorite type of question that comes out, because if you take a look at this, by identifying the sides, I immediately found out what A was equal to. Once you know what A is equal to, you might not even have to do any work for it. You take that value and you just kind of slide it into all of the A locations in the pattern. So really didn't have to do much work other than just identifying. Okay, question number 2, same idea. Just pause it, see if you can do it. Remember, identify the sides, and then A is the key. If you know A, plug it all in, see what we get. Okay, 2 is another nice one. You'll notice that we found immediately what A was equal to. Once you know what A is equal to, just slide it into the pattern where it belongs. All right, why don't you see if you can give 3 and 4 a shot. Actually, let's just do 3 first. 4 looks a little crazy because of the root 5. So let's take a look at number 3. See if you can go through, do number 3. Remember, the key is to find A. Once you calculate what A is, then drop it into all the other locations where A is in the pattern. Okay, so on this problem, we were given the hypotenuse, which is good because we need to solve 2A then. That's not too bad. We're going to go ahead and take that equation off to the side like I did. I'm going to solve for A and make it A is equal to 8. Then go back up to the other sides where I have those equations and drop 8 into all of those locations. So it looks like we get Y is equal to 8 and X is equal to 8 root 3. Okay, now for number 4. Number 4, I'm going to go ahead and identify my sides just like I normally would. So there's my 30, which means that's A. All right, that doesn't do me much good. 60, A root 3. All right, and then opposite the box, that's going to be 2A. Okay, I don't think this one's too bad. We're going to go ahead and take the equation that we can actually solve for A and take that off to the side. So we'll get 2A is equal to 8 root 5. All right, we're going to have to divide by 2 to get the A by itself. Those 2's cancel. Okay, this really isn't that terrible at all. All right, it looks like we can simplify the 8 and the 2 because neither of which are inside the root. So I think that's going to give me 4 root 5. So just carry the root 5 with you. All right, let's go plug it back in. So that looks like there's an A, and then drop the Y down. Okay, I think that's going to be one of the solutions that we get there. Then if we take a look at the other one, we still need to drop in the 4 root 5 here. So we're going to drop in the 4 root 5. But don't forget we still have that root 3 and drop the X straight down. Well, since both the 5 and the 3 are inside roots, we can actually multiply them. So let's go ahead and do 4 times root 15 and drop the X straight down. All right, it looks like we now have our answers here. The box cut off the edge of it. All right, so let's go ahead and write those out. So it looks like Y is equal to 4 root 5, and it looks like X is equal to 4 root 15. All right, those are our 2 answers on this question. All right, let's move on to the next slide. Okay, this is the last one that we've got. So we've got 4 practice problems on here. So my recommendation, see if you can do them. So let's do 5, come back and check. 6, come back and check. Likewise with 7, and then with 8. I do want you to come back and check after each question. We don't want to keep doing something incorrectly, so do one problem at a time, come back and check your answer. Okay, so here are my answers for both X and Y on question number 5. And then once you're done taking a look at this, give it a pause. Let's see how you do on question number 6. Okay, here's my work for question number 6. You want to take a look at this one. You have to not only set up the little equations for each of the sides, but you do have to rationalize this one and then simplify it. So it looks like we get that A is equal to 2 root 2, and then we'll slide those into the locations that they belong. It looks like both X and Y are the same length, which they should be. They're the legs of a 45, 45, 90 triangle. And we get 2 root 2. Okay, once you pause it, see if you can do question number 7, come back and check your work. Okay, so taking a look at question number 7, we did have a given to us, which is actually really nice. Oh, and I see that I made a mistake, so let's actually fix x. I'm not totally sure why my brain decided partway through that this was a 30, 60, 90 triangle, which it is not. Okay, so we know that this is actually going to be a root 2. All right, let's put that in. So 3 root 2 over 2 times root 2. Okay, I'm going to put a 1 underneath that root 2 so I can multiply these. Notice that the root 2 and the root 2 are both inside roots. So that guy and that guy, which means I can multiply them. Oh man, okay. So this is going to be 3, carry the 3 with me, root 4 over 2. All right, that can still be simplified. Root 4 is actually 2. And I think I can simplify the 2's. All right, it now looks like I have that x is equal to 3. There we go. That makes more sense. And then I have my answer for y already. All right, last one. See if you can pause. Actually, go ahead and pause. See if you can do the problem for number 8. Come back and check. Okay, since we have a 45, 45, 90 triangle, went through and identified my sides. Notice the equation that I could solve is the one that I keep highlighting. So it's the 2 root 6 is equal to a root 2. I'm going to go ahead and simplify by dividing by root 2 on both sides. If you take a look over here at my work in solving for a, you see that I have a root 6 and a root 2. Since they're both inside the roots, I can actually divide them. That's where I got the 3 from. Then I'm going to go ahead and plug in that 2 root 3 for a everywhere throughout the triangle.